right? So what are elementary transformations? Let's look at elementary transformations. So what are elementary transformations? Can somebody tell me, what do you think is an elementary transformation? Huh? Exchanging of two rows, right? That's any two rows, right? Exchange of two rows, right? That's an elementary transformation. If I exchange row 1 and row 3, right, I can do the reverse, right? What is the reverse? You exchange it this way. So that's invertible transformation. Do you agree? But we don't know whether it's linear or whether it amounts to multiplying it by another matrix. That's something that we should verify. But you understood what it means, right? Do you agree? Okay. So what is the next one? Scaling a row by a non-zero constant. That's true, right? I take the fifth row and multiply by 6. I can get back the original matrix by dividing the 6, whatever the row by 6, right? So that's invertible. Okay. So what is the third one? Replacing a row by a linear combination of other rows. Okay. So replacing a row by a linear combination so what do I mean by that? So you can just for example, I can take a row, multiply it by a constant and add it to the previous row, and the resulting vector is what I'm going to write, okay, of rows, right? These are elementary, right? But the only thing is you should be able to check that, you should be able to get back, right? First two things are very clear, right? Very easy. What about the next one? Okay, just to convince ourselves that this is invertible transformation, we don't know whether it's linear. So suppose I have this vector, okay, so A, and you have another B, okay, and you have in between also, okay, this is a matrix. So I'm going to replace B by lambda A plus beta B, okay, so that's what I'm going to do. A as is dot 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 lambda A plus beta B dot dot dot. Okay, I know what lambda is, I know what beta is. Okay, so now can I get back the original? Easy, right? I know that I have taken this particular row, so I know A, right? I know lambda A, I know beta, but I don't know B, right? I have to get back B. So, but I know lambda A plus beta B, I know everything except B in that, right? So I can get back. Is this clear? It's invertible. Okay, so that means this is also invertible. So all these elementary operations are invertible. Okay, fine. So now if they are invertible, let's look at what does it translate to in terms of matrices, right? So let's look at the first one, exchange of two rows. So let me have a matrix like this, A1, A2, and so on, AN. Okay, I want to exchange, for example, A1 and A2. So what is it that you will multiply so that you will exchange these two matrices, these two vectors? The first row should be exchanged by the second row, basically swap. What should I do? Whenever I multiply it, the first row should be the second row, right? The second row should be the first row, right? The remaining should remain as is. So what do I do? See, this is what I can do, right? 0, 0. What do I get now? If I multiply this, so it will select the second row, right? Naturally, right? So the first row will get second row, but second row I should get first row. What should I do? Right? Okay, exchange is done, but what about the rest? Rest should be identity matrix, right? So whatever. So how do I select? Third row should be chosen by this. So this means 0, 0, 1, 0, etc. 0, 0, 0, 0, 1, 0, etc. 0, and so on, 0, 0, etc. 0, 1. Right? That's how it should be. So what is the relationship between this matrix and an identity matrix? Huh? What is the difference between this and identity matrix? If I swap the first, so if I take this matrix, right? If I swap the first and second row, I get identity matrix. Do you agree? So it's in some sense, not in some sense, it's basically permutation of identity matrix. If you take an identity matrix and permute and multiply it with another matrix, it's essentially equivalent to swapping the rows, right? Is that clear? Okay, so multiplying by permuted identity matrix. I'll call this as n cross n identity, whatever. Okay. Okay. So what about the second one? Multiplying a row by a constant. So how do you do that? Same thing, right? So for example, if I want to multiply the ith row by lambda, all that I have to do is take the identity matrix, put lambda in the ith entry, right? Ith diagonal, right? That's all I have to do. Is this easy? So this is the second one is easy. Okay. So what about the last one? I have to multiply one row by some constant, the other row by some other constant, add them to get this. So what should I do? Yes. What should I do? Huh? See, you know how to multiply constants, right? So let's do step by step. So what should I do first? Let's say I want to multiply by, let's say alpha here and then say beta here, one in between, and then identity 0, 0. So what does this give us? It will basically multiply the ith row by alpha and jth row by beta, right? So accordingly. Now I have to do what? I have to add them to get the next one. So how do you do that? So let me call this matrix as B. Okay, B will give me appropriately multiplied. Okay, so I should not do this, right? What should I do? If I do this, then okay, so I'll take this back. So if I do this, that's not enough. So let's look at a simple example. Okay, so maybe a 3 cross 3 matrix. Let's say A1, A2, A3. So I want to get, for example, A3 as alpha times A1 plus beta times, okay, so this is A1, A2, this is alpha times A1 plus beta times, well, what should I take? I cannot take A2, okay, not the linear. I should also include this, right? Some constant times this plus some constant. So I cannot exclude A3. If I exclude A3, what will happen? See, one row is a linear combination of the other two rows, and you are changing the property of the matrix, right? Completely. That's not allowed. Okay, I think maybe I should. Okay, so I should caution here. The row under consideration should be included. Okay. 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 So let's see. So how do you write this thing? Beta alpha A1 plus beta A3. What should I do? Right? So you have basically 1, 0, etc. 0, 0, 1, etc. 0 identity, right? And so on. Okay, so 0, 0, etc. There will be okay, 0, etc. Maybe I'll write it like this: 1, 0, right? The last row, if I write all 0 except last, which is 1, I'll get identity. I'll get back the original matrix. So what should I do? I should take alpha in the ith entry here, beta in the jth, No, not jth. The last one, right? I should include the last one. So 0 elsewhere. Okay. If I do this and multiply by, for example, A1, A2, A3, what do you get? The last one would be what? It will select the ith row. Okay, so I here is ith and jth could be at least 1, 2, 3, right? So, but in general, this is what. Let's look at an also. Okay, you have n cross n. Hmm? So in this case, it will select the ith row, multiply by alpha. It will select the jth row, multiply by beta, and it will sorry, the last row and multiply by beta and add them, right? So this is another elementary. This is also an elementary matrix. Okay, it's an elementary transformation. So what is this? So essentially, you are not only permuting, you are adding some alpha, beta here and there, right? So it's an invertible transformation. Okay.